real number unit, and this is talking about squares and square roots. These are some of my favorite numbers, and they are extremely useful. First one is squaring a number and square roots. What do we mean by that? And what do you need to write on your notes outline? First of all, squaring a number is the same as multiplying the number by itself, or raising the number to a power of 2. For example, 4 squared just means 4 times 4, and it equals 16, as we've illustrated in this little phrase here. Be careful to note negative signs in parentheses when you're squaring values. Observe the difference below. For example, if I have negative 2 squared, that's like saying negative 2 times negative 2, and a negative times a negative is a positive, so you get positive 4. On the other hand, when I have something like this next one, that's like saying the negative of 2 squared. And 2 squared is 4, and then a negative of 4 is negative 4. And so you can see the same thing illustrated with negative 3 in parentheses squared, which equals 9, and the negative of 3 squared, which equals negative 9. So that's a common place where people get tripped up, so make sure you watch out for that. The square root of a number is the value that multiplied by itself equals that number. For example, the square root of 16 is both 4 and negative 4, because 4 times 4 equals 16, and negative 4 times negative 4 equals 16. So the word that's up here that's missing is itself. Now the positive square root is known as the principal square root, and that's the one that we use the most. But there is such a thing as a negative square root, and sometimes you'll be asked to produce that number. Any number with a square root that is a whole number is called a perfect square. If, on the other hand, a square root has a decimal, it's not considered a perfect square. Complete a helpful resource for the first 15 squares and square roots by filling out the table below. So we're going to go ahead and fill out this table. So 1 squared would just be, I better get the right pen here. 1 squared would just be 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 16. 5 squared, 25. 6 squared is 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared would be, well, we better figure that out. 13 squared, I gotta grab my calculator. So 13 times 13, I'm doing on my other screen, is 169. 14 times 14, 196. And 15 times 15 is 225. All right, so we can use the same reasoning and logic that we used up here to find out the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. We're basically filling all of these numbers in for the square roots. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. And the square root of 225 is 15. So there's your first 15 perfect squares, and that'll come in handy as we go along. Okay, which of the following is not an example of a perfect square? Well, we know that the square root of 4 is 2, square root of 9 is 3, square root of 64 is 8. I guess the square root of 200 is the one that's not a perfect square. A perfect square is a number whose square root is an even number. Okay, which of the following is a true statement? Well, we've seen from the squares that we looked at a minute ago that not every perfect square has to be an even number. So this is not a true statement. The inverse of squaring a number is to divide the number by 2. That's incorrect. The inverse of squaring a number is to find its square root. So the last one, to square a number, multiply the number by itself. That is the true statement here. Explain the difference between negative 5 in parentheses squared and negative 5 squared. Explain the difference between negative 5 squared and in parentheses and then negative 5 squared. Well, the first one is like saying negative 5 times negative 5, which ends up being 25. Meanwhile, the next one, the last one there, is like saying negative of 5 times 5. So 5 times 5 is 25, so then you end up with a final answer of negative 25. So the main difference is one's positive and one's negative. Okay, so let's evaluate the following squares and square roots. So negative 7 times a negative 7 is 49. What about on a fraction? Well, I just do 2 times 2 over 3 times 3. So that just gives me 4/9. All right, and my last one, I've got the negative of 9 times 9, which ends up being negative 81. All right, you're getting the idea? Okay, now this symbol, the square root symbol, is a real number only if x is a positive or if it's 0. If x is negative, then the square root is not a real number. In fact, there is such a thing as negative square roots, and they're called imaginary numbers. So which square root is a real number? Well, this one, you're actually taking the square root of a positive 4, which gives you a final answer because of that negative out front of negative 2. On these, you're both trying to take square roots of negative numbers, which at this point we don't know how to do. So those are not real numbers. Okay, how about these? The square root of 196 and the negative version of that. So the square root of 196 is 14, but the negative sign is out front, so that's going to be negative 14. How about the square root of 0.81? So the square root, I'm getting my calculator, you get your calculator, and do 0.81 and square root of that, and you end up with 0.9. That's an interesting number. If you think about it, isn't 9 times 9 81? Then 0.9 times 0.9 is 0.81. Okay, so in this problem, we're doing the square root of 9 over the square root of 16. That's how we do a problem that looks like this. So the square root of 9 is just 3. The square root of 16 is 4. So that just ends up being 3/4. That's a lot easier looking than you were expecting, right? Okay, what about these? Here it says to simplify the fraction first and then find the square root of each one. So 50 over 18, I can divide that by 2, divide this by 2, and that would give me the square root of 25 over 9. And then the square root of 25 is just 5, and the square root of 9 is 3. So pretty slick. On this next one, we are going to divide the top and the bottom by 3. And I'm kind of being selective about what I divide it by because I know that 75 divided by 3 is 25, which I already know is a perfect square. And then 12 divided by 3 is 4. It also is a perfect square. So when I do the square root of 25, I get 5. And the square root of 4, I get 2. So my final answer on this one is just 5/2. On our last example here, I'm going to divide each of them by 2. That will give me the square root of 9 over 16. And if I do the square root of 9, I just get 3. And the square root of 16, I get 4. So that last problem is 3/4. Okay, what if you have the same kind of thing with a couple of problems that look like this? Well, first of all, in this first problem, we're going to do the square root of 64, which is just 8. Then we're going to multiply it by 2. So that gives us a total of 16. Not bad, right? How about the square root of 121? Well, that's just 11. So then we can take that 11 and add it to the 5 that was out in front. 5 plus 11 is... So 5 plus 11 is just 16. So there's that one. On our last little problem here, we've got the square root of 225, which is 15. So now I'm going to multiply by -3. I'm not sure why I put that box around it. I meant to put parentheses. The -3 times 15 is -45. And then we're going to add 10 to that. So -45 plus 10, it gives me a net result of -35. All right, just a couple more problems. And look at them this way. So this one, we've got square root of 114. So let's do it, 114 square root. That would give me 10.66 minus the square root of 36 is 6. So 10.66 minus 6 is 4.7 if we round it to the nearest tenth. On our next one, 15 times the square root of 16. Well, the square root of 16 is 4. So 15 times 4, well, that's just a nice 60. That worked out really nice. Then our last one up here, -81. The negative square root of 81 would be -9. -9 plus 20 gives us a final sum of 11. So these come in all kinds of shapes. So the negative square root of 4 would be -2. Can't do a square root of negative, so that doesn't work. Can't do a square root of negative 25, so that doesn't work. However, the negative of the square root of 16 is negative 4, or the negative square root of 16 is one way to say it. So how about this one? A group of 225 students needs to be arranged in a square formation for a halftime performance show. How many students should be lined up in each row? Well, if you just do the square root of 225, you end up with 15. So you're going to have 15 rows of 15 people to get them all lined up in a perfect square. Okay, Ivan's room is a square with an area of 144 square feet. What is the perimeter of Ivan's room? Well, if we have a square, we know that the area is just side times the side. So if side squared, which is the area of a square, is 144, then we know if we take the square root of the 144, we will get the amount of one side, which is 12. So each side of the room is 12. And if we go all the way around and apply that 12 to each side, 4 times 12 would be 48 feet. Write that down. Number 50.